In this next section, I'm going to go over some examples using the Bayesian decision analysis software. So in a separate section, I'll introduce the use of the Bayesian decision analysis software. It is called IHDA, Industrial Hygiene Data Analysis, and LE stands for Light Edition. It is a free piece of software, and I'll talk about it more in a different section. The data is entered using a grid similar to an Excel spreadsheet, and you can enter information on the facility and substance and comments and data, and all the information can be saved to an Excel compatible file. And also exposure data can be pasted from an Excel spreadsheet onto the data grid. And the sample size for the light edition is limited to 50. So this is a screenshot from this data entry page of this software. And so you can see in the top part, you can enter information about the facility and the department and process and so on. These you can enter or not as you see fit for the purposes of this course. But what is really important is that you enter the value of an exposure limit and the units for that. And so in this example, the OEL is 5 milligrams per cubic meter. And in the bottom part of this are the actual data points. So in the column marked CONC, concentration, that is where you would enter the exposure measurements. So we have 6 data points here, 1.63, 4.28, 2.04, and so on. So once you enter these data, you can also, in the third column, specify if any of these data are below the limit of detection. And we'll discuss that later, but for at least the first data set, none of these data are below the limit of detection. And at the top of the software package page, there's a button called Calculate All, and it's easiest to just press that button every time. So you press the Calculate All button, and you can review the traditional statistics first and look at the goodness of fit or GOF graphs and make sure that the assumptions that are built into this software are met, meaning the data are stationary and consistent with the assumption of a single mode log normal exposure distribution, and also whether the exposure profile is likely to be within the parameter space, and then look at the decision charts. So what we are going to do first is look at this hypothetical workplace where there are some processes occurring, and we'll look at process operator 1 first, and then later on look at process operator number 2. So in this first scenario for process operator number 1, this person is responsible for several tasks: opening a valve that directly charges xylene into a process mixer, manually charging solids into the process mixer, and then collecting multiple quality samples once each hour. And no previous personal air measurements have been made, but now we collect some full shift air samples, and now let's do some Bayesian decision analysis, or BDA. So we have collected 3 data points, 13, 26, and 18, and these have already been entered into the second column of the spreadsheet, the bottom of the left-hand side of this page. The OEL is 100 parts per million, so that's been entered. And let's start off with a uniform or non-informative prior, meaning that the probability is 0.2 in each of the 5 categories. So at the top left-hand side, you see the Calculate All button. So after entering your 3 data points and the facility information, you can press the Calculate All button, and we can then look at the decision chart. So the likelihood decision chart here shows that there is a 60.2% probability that these 3 data points come from category 2 exposure. And we also see that there is a 14% probability in category number 4. And so how do we interpret this? Well, it's tempting to say, okay, it's a category 2 exposure and stop there. But really, we need to remember also that the amount of probability in category 4 exceeds the 5% that we have set as our limit of acceptability in category 4. And so the way to interpret this is to say that we have a 14% probability that process operator number 1 requires additional exposure controls. And clearly, this is above our acceptable threshold, meaning it's unacceptable. And we can again compare our clear statement saying we have a 14% probability that process operator 1 requires additional controls compared to the traditional statistics, which we can only say that the population 95th percentile point estimate is 32 with an upper confidence limit of 260, which is not that useful from a decision-making perspective. Now, let's go ahead and collect another sample. So now we have 4 data points, and we can again say, okay, let's start. We have an OEL of 100. Let's start with a uniform prior of 0.2 in each of the 5 categories. And now we have a 72.6% probability in category 2. And we now have 7.4% in category 4. And how would you interpret this? Well, there are several ways in which we can go at this point. One is to say, and the safest thing is to say, that we are still above the threshold for acceptability in category 4. So the threshold is 5%. We are above that. So we would still say this is unacceptable, and maybe we need to go and collect maybe 1 or 2 more samples because we can clearly see the trend. I mean, it looks like it's a category 2, but we are not certain enough about it to meet our acceptability criterion. Or we can go with our gut feeling and say, I think it's a category 2, and I don't really need another sample to tell me that. And the way I would do that, I would just say I could stop at this point because I got instinct that this is going to be category 2. But the safe thing to do if you were to strictly follow this software is to say, okay, let me go and collect 1 more sample, and that will probably bring the probability in category 4 to below 5%. So these types of decision charts are very useful to us, and they provide us a means for communicating the decision in probabilistic terms that are easily understood by experts and layperson alike. So let's say for example number 1 in this chart, we could say that there is a 72% chance that this is a category 1 exposure, and there is a very minute chance that exposures are exceeding the OEL, so almost 0.1% probability. Whereas in example 4, we can say that there is almost 100% probability that this is a category 4 exposure. Or in example 3, we can say there is a 27% chance that we are in category 4 and almost a 58.9% probability that it's a category 3. And again, compared to the traditional statistics, these are more easy ways of communicating our decision making. So we can say things, for example, in the first bullet, given our sampling data, we have a greater than 95% probability that exposures are acceptable, or greater than 27% probability that exposures are unacceptable, and so on. This is another screenshot from the BDA software tool, and I'll talk more about this in another unit, but what it shows us is we can control the exposure category cutoffs. So in this type of decision chart, we have clicked on the right-hand side top. We said we need 0 through 4 exposure zones, which is what we have selected here. But we could also pick from one of several other options corresponding to 1 through 5 exposure zones, which is the AIHA model, or the EU control bands for particulates or vapors. We can also set the boundaries for the exposure categories on the left-hand side of this chart. But for now, we have it set at the categories 0 being at 1%, category 1, the boundary is at 10%, category 2 is at 50%, category 3, the boundary is at 100%. And the default parameter space for an OEL of 1 has a GSD minimum at 1.01 and a maximum at 4. And the GM minimum and maximum are shown in this screenshot from the software tool. The minimum is at 0.0005 times the occupational exposure limit, and the maximum geometric mean is at 5 times the occupational exposure limit.